So today's lesson is lesson 1-3, which is factors and multiples. This is part 2. We're talking about least common multiple, okay? So the first thing you did was you watched 2 videos, and this is just review. The videos that you're reviewing were place value and rounding decimals, okay? So the first thing I would like for you to do is to write these definitions in your notebook. So the first one is for multiple. Multiple is a product of a given number and another number. The least common multiple is a least non-zero number that is a multiple of 2 or more numbers. Now, multiples go on forever and ever and ever. They go on to infinity. So when it says a product of a given number and another number, for example, if I want the multiples of 2, I've got 1 times 2, 2 times 2, 3 times 2, 4 times 2, and so forth. Okay? We want to list the multiples of 3. So again, that means we're just going to take 3 and we're going to multiply it times 1, times 2, times 3, times 4. You don't have to write all that. Times 4, times 5, times 6, times 7, and so on. Okay? So the multiples of 3 then would be 3 times 1 is 3. 3 times 2, 6. Then 9, 12, 15, 18, 21. Does it stop there? It just keeps on going and going and going until infinity. So we're just going to put dot, dot, dot. Okay? So again, it goes on forever until infinity. So, for example 1, we're looking at we want to find the least common multiple. It says every 10th week, Tamika visits the zoo. Every 12th week, she visits the local pet rescue. If she visited both this week, how many weeks will it be until she visits both the same week again? Okay? Now, some key words that will tell you that you're looking for the least common multiple is both. When will we do this again in the future? Does everybody see that? Okay? Those are the words that will help you decide between greatest common factor and least common multiple. So what's the important information here? So every 10th week, she visits the zoo, and every 12th week, she visits the pet rescue. Now, again, if she visits both this week, in how many weeks will she visit both again in the future? Is everybody clear? So this is how we're going to know that this is a least common multiple. All right, so let's write this down. We've got the zoo, and we've got the pet rescue. Okay? So it says every 10th week and every 12th week. And we're going to just use a list of multiples to figure out this problem. So every 10th week and every 12th week. So let's list our multiples. So the multiples of 10, let's see, let's do the next multiple is, for 10 is 20, and then for 12 is 24. Okay? The next one is 30 and 36. And then the next one is 40 and 48. So far there's no matching up, right? Okay, let's see. Then we've got 50 and 60. And then we've got 60 and 72. So do I have a match? Yeah. So this is going to tell me, this is my least common multiple. This is going to tell me when she's going to go to both of them again on the same week. Is everybody clear with that? So the least common multiple is 60. So the 60th week is when she will visit both of them again. If the numbers were like, I don't know, 38 and 125, would we want to make a list of all those multiples? No way, no way. So, because we don't want to make lists all the time, we can use our factor trees or the cake method. So for this next example, we're going to do the factor tree. Okay, so we want to find the least common multiple of 6 and 8. All right, so for 6 and 8, least common multiple, we're going to use our factor trees. So remember yesterday, we just wanted to know, what are we going to break these down to? So 6 can be broken down to 2 times 3. Remember, you want to put the factors on the tree. And then 8 can be broken down to 4 times 2. Good. And then are those prime? No, we can break down the 4 to 2 times 2. And then don't forget to bring down that 2. Now, remember yesterday again, we lined them up. Okay? So for 6, we've got 2 times 3. For 8, we have 2 times 2 times 2. Now, to find the least common multiple, we're going to multiply what they have in common, and we're going to multiply everything else. Okay? So what they have in common is this 2. So we're going to multiply 2 and everything else, 2 times 2 times 3. Is everybody with me? So now we can simplify that. What's 2 times 2? And then 2 times 3. So 4 times 6 is 24. So 24 is my least common multiple. All right, so here you don't have to write down the whole thing. Just write down what we highlight. It says, how do you use prime factorization to find the least common multiple? So how do you find least common multiple? It says multiply the prime factors using each common prime factor only once. In other words, you are going to multiply what they have in common, that's the GCF, and everything else. So you multiply what they have in common once, okay, so that's the GCF, and you're going to multiply everything else. So here we want to find the least common multiple by using the prime factorization or the cake methods. So we're actually going to do both, okay? So let's do 32 and 28. Let's use our prime factorization, our factor trees. So we've got 32 and 28. So what can I break 32 down to? 16 times 2. I like to do a little bit bigger numbers. Yeah, I like to do that better. Okay, 4 times 8. And the only reason I choose the numbers that are closer together is so that my factor tree is not so lopsided or long. Okay, so now the 4 can be broken down to 2 times 2, and the 8 can be broken down to 2 times 4. Are those all prime? Not yet. What can I still break down? The 4. So the 4 can be broken down to 2 times 2. And then don't forget, I want you to also bring down the rest of the tree. So there is our prime factorization for 32. For 28, what can we multiply? How about 4 times 7? 4 times 7. And then, of course, the 4 can be broken down to 2 times 2. And then don't forget to bring down that 7. All right. Now, To find, I'm going to come down here, the least common multiple. Actually, we want to line them up, column it up. So for 32, this is equal to 2 times 2 times 2 times 2 times 2. 28 is equal to 2 times 2 times 7. Okay? So we want to find the least common multiple. We want to multiply or write circle what they have in common. So we have 2's in common here, 2's in common there. Anything else I can circle? No. So we've got 2 times 2. And, you guys, we have to multiply everything else. So this is going to be times 2 times 2 times 2 times 7. So now we can simplify, right? So 2 times 2 is 4. This 2 times 2 again is 4. And then 2 times 7 is 14. So 4 times 4 is 16. So 4 times 4 is 16. Times 14, what do you get? So 224. And this is your least common multiple. So now, you guys, let's take a look at how it looks like with the cake method. Okay? So with the cake method, again, we've got 32 and 28. Okay, here's 32, here's 28. What prime number can I divide into 32 and 28?
4.
Is 4 prime?
Why not?
What can I divide into there? 2. So 32 divided by 2 is 16. And 28 divided by 2 is 14. Okay, so here's my next layer. So, what prime number can I divide into 16 and 14? 2. So 16 divided by 2 is 8. And 14 divided by 2 is 7. All right. Can I divide a prime number into 8 and 7? No, I can't. So here, you guys, here we've got our GCF, which is what they have in common, and here is the everything else. Is everybody with me? So to find the least common multiple, we are multiplying 2 times 2 times 8 times 7. And look, it even looks like an L, right? Look at that. So 2 times 2 is 4. 8 times 7 is 56. And then 4 times 56 is 224. Is everybody clear? Which one do you like better? Good. So you will end up with the same thing. So here, you guys, this is what the prime factorization is using exponents. Now, yesterday we looked at we took the smallest. When we're doing a GCF, we took the smallest exponent, right? What did we take when we're finding the least common multiple? The greatest exponent. See, 1, 2, 3, 4, 5. This is what we multiplied. And the 7. Is everybody clear? Very good. So Grant buys bottled water and juice pouches for a picnic. There are 12 bottles of water in each case and 10 juice pouches in each box. Grant wants to buy the same number of waters as juice pouches. but no more than he needs to have an equal number of each. How many cases of each should he buy? Okay? So, the first thing we want to do is write down our important information. What's important? Call it out.
Every 12 and every 10.
Right, so here there are 12 bottles of water in each case. That's important too, in each case. And there are 10 juice pouches in each box. Okay? So he wants to have the same number of waters and juices, but no more. Okay? So this is what's telling us that we're looking for a least common multiple. We want to know, we want to know how many cases of each should he buy. So let's do this one with the cake method, okay? Since the first time we did it was just a list, right? So let's do this one with the cake method. So here we have 12 waters and 10 juices in each case and box. All right, so what is the prime number I can divide into 12 and 10? 2, good. So 12 divided by 2 is 6, and 10 divided by 2 is 5, okay? So the least common multiple, we're going to multiply. Here's the greatest common factor, that's the GCF, and here is the everything else. Is everybody clear? So to get the least common multiple, we're going to multiply 2 times 6 times 5. So 2 times 6 is 12, times 5 is 60. So this is 60 waters and 60 juices. 60 waters, make sure we label, and 60 juices. Is that my final answer? No, because of the way the question was worded. We want to know how many cases should he buy, right? So if we want 60 waters, because there are 12 in each case, we're going to divide by 12. So that gives us 5 cases. Very good. Make sure you write that down so you can show your work. For 60 juices, what are we going to divide by? We're going to divide by 10. We're going to divide by 10 because there are 10 juice pouches in each box. So that's going to give us 6 boxes of juices. Is everybody clear?